Let's work a little bit more on constitutional isomers. And now what I'm going to do is take some specific formulas and write some specific compounds. So for example, the question is, write 3 ethers of C4H10O. So first of all, you have to know what an ether is, which is ROR. So you have to have 2 carbons on either side. So here we have 4 carbons to work with. And so we will start with the first one. 1, 2, 3 carbons. Oxygen, 1 carbon. 1, 2, 3, 4 carbons and an oxygen. Okay, so that's our first ether. And then we have 1, 2, 3, 4, that one. And then we can have a branching going on. That ether. 1, 2, 3, 4. Okay. One of the quick cross checks to do is count your hydrogens. Okay, you should have 10 hydrogens. And so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If one of them is correct, then everything else should be correct also. So that's how you would draw constitutional isomers for this first one. The next one is 3 primary alcohols. 3 primary alcohols of C4H8O. One of the things I want to mention is about this count of hydrogens. Over here, if you see now, we have a little bit difference here from what we had here in the first one. C4H10, that was the ether question, and now we are C4H8. So something is different. The number of hydrogens is different. So the first thing that we should do technically is always do the alkene formula calculation. So CnH2n, and this is for an alkene, and it's easy to go plus 2H to give alkane, and if it is minus 2H, then it's going to be an alkyne. Okay, alkyne means triple bond. Okay, and alkane means complete saturation. So C4H8, so C4H should be 8. It means it is an alkene or 1 double bond. Okay, that's what it means. That is how I'm thinking when I think about my constitutional isomers. The oxygen here is not going to count. Okay, oxygen just fits into the molecule. All right, so we don't have to worry about what happens to the oxygen. It will just fit in. So we'll start with 3 primary alcohols of C4H8O. So we have 4 carbons to work with, but we have to have a double bond or 1 ring. Okay, cycloalkanes always lose 2 hydrogens when you form a ring. So we can start with a simple one. 1, 2, 3, 4, and then OH. Okay, and so we have to have a double bond. I would suggest don't draw the double bond on the carbon next to the alcohol. All right, so here is one. Move the double bond. Here is another one. You can have branching going on. So remember, we have to have primary alcohol. All right, so it's only primary alcohol, so we can have this. Count the number of hydrogens if you want to. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. All right, so we need 3 primary alcohols. So that's what we have. We can still draw more. Okay, and I'm going to see if I can do this without drawing a double bond. Okay, so we'll actually have more. So let's draw a cyclopropane ring now. And here is my 4th carbon. That still makes it a primary alcohol. All right, so this would be the final structure. Let's take another one. Tertiary halide of C5H11Br. Tertiary halide meaning so you have to have a carbon connected with 3 other carbons. Okay, so tertiary 1, 2, 3, and this is C5H11, by the way. When you have halide groups and you do the CnH2n formula with this, you have to replace the alkyl with the hydrogen. Replace alkyl, the halide, with hydrogen to calculate saturation. Okay, that's what you need to do. So our CnH2n here would be C5H10, but we have C5H12. Therefore, this is an alkane. Alkane meaning all straight chains, okay, and only single bonds. So now that we know what we have, go ahead and draw 3 carbons and make sure you have a tertiary halide to begin with, okay. So once we have the tertiary halide, now we can go ahead and put in the rest of the carbons. So 1, 2, 3, 4, 5. You can put the carbon wherever else you want. D, 3 secondary halides of C5H11Br. Okay, so now same formula, so we don't have to do the calculation again, but we have to have a secondary halide now. So C5H11, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and secondary halide meaning that way. Okay, something that is connected to 2 carbons. I can move it once more over here. That will give me another one. And then the third one that I will get is by branching. Okay, and so let me go ahead and draw my secondary halide first. 1, 2, 3, 4, and here is my 5th carbon. Okay, so those are my 3 secondary halides. Let's do another one. And now let's do aldehydes. 3 aldehydes and 3 ketones, okay, of C5H10O. All right, so now you have C5H10O, and C5H10 tells you right away that you have CnH2n, which means a double bond, which is fine because you have aldehydes and ketones, which require a double bond. It's not between carbon-carbon, and it doesn't matter. So C5H10O, aldehydes are terminal, so which means that you need to have them at the end. Okay, so 1, 2, 3, 4, 5. So which means the aldehyde group has to stay the same. You can move anything else. So the next one that I will do is with 4 carbons, 1, 2, 3, 4. Here is my aldehyde, and I move 1 carbon, and I can move it once more, and here. Okay, so those are my 3 aldehydes. Yes, I can have one more. If you're getting adventurous, then let's do one more. Here is that, and here is the aldehyde. Okay, 1, 2, 3, 4, 5. There, so we can have up to 4 actually. All right, now for the ketones. Ketones have to be in the middle. They are considered to be internal groups, so this is all you can do. 1, 2, 3, 4, 5, and then we can move our ketone group once, put it in the middle, and then the third one would be from the first one. So let's go ahead and make our ketone first, and then we will do one branching. Okay, let's do one last one. And amines of C3H9N. Okay, and so all amines that we can draw for C3H9N, and then we will classify them also. Okay, and classify them as primary, secondary, tertiary. So let's start with a simple one, C3, 1, 2, 3, and then A. Okay, over here. And so this is a primary amine, so which means I have to put a 2 over here, H2 over here. So C3, let's go ahead and count our hydrogens to make sure everything is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are fine. And this is our primary amine. We can have one other one maybe. NH2 and that. Okay, and so that is still primary amine. Then I think that's about it that we can do with the primary amines. Let's do a secondary amine For secondary amine, remember only one hydrogen. Okay, so which means we have only 3 carbons to play with. So this is all that we can do, okay, for a secondary amine, which is a methyl group and an ethyl group. Okay, that's about all we can do. And then we can have the tertiary amine, which requires 3 bonds, no hydrogens, and this is all we can do for a tertiary amine. So CH3, 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 that takes care of the 9 hydrogens. So that's how you would do this kind of a constitutional isomer.